how we are going to find the middle element of the array? Low plus high divided by 2 will give us a middle element of the array. What is a low value? 0 is a low value plus 3 is a high value divided by 2. What I am going to get? I am going to get the value as 1. We have to do the two partitions or two functions called, one is merge sort to merge the element of the array which is divided, and one is partition, means dividing the element of the array. Hello everyone, welcome to the one more session on the data structure for second semester B.Ca student. We are discussing on the unit 2. Today in this session, that is session 5, we are going to discuss about the operation on array, especially on the merge sort. Myself, Indu J, Faculty of Computer Science Department, Vidhyaashram First Aid College, the Temple of Excellence, Mysuru. So let us start today's session. What is merge sort? We have seen different kinds of sorting techniques like bubble sort, selection sort, insertion sort, quick sort, and one more type of sorting is merge sort. You know why sorting is used, sorting algorithm is used. Sorting algorithms are used to sort elements of the array in a sorted manner. Why we need to sort the array? Once we have a sorted array, elements are in sorted manner, it makes the searching is very easy. So we are using a sorting techniques to make the searching easy. So what is merge sort? As a name itself indicate, we are merging some solution. So that's why it is called as merge sort. This is also as a quick sort, we use a divide and conquer technique. Here also we are using a divide and conquer technique. Exactly what you know the divide and conquer, how does it work, divide and conquer? First, we are dividing a complete problem into smaller sub-problem and finding a solution for the smaller sub-problem. Once we find the solution for the smaller sub-problems, we are merging those smaller solution to find the solution of given problem. That is what the divide. Divide means we are dividing into sub-problem. That is one phase of the divide and conquer technique, and merging, combining the solutions is one more phase of the divide and conquer. Conquering the given problem by solving the smaller problems, that what we can say. So merge sort, it follows the divide and conquer approach. As just now I explained you, a larger problem is divided into smaller sub problems, that is called as a divide stage, and all the small sub problems are solved and merged together to get the final solution. All the sub programs are solved and merged to get the solution for given problem. That what we call it as a conquer stage. So let's see what the merge sort algorithm will exactly do. In the merge sort algorithm, we have to divide the given array on particular constraint basis. How we are going to divide? We are going to divide based on this formula. What is the formula? We have to find the middle element of the array. How we are going to find the middle element of the array? Low plus high divided by 2 will give us a middle element of the array. First, find the middle element of the array by using this formula. Okay, if I have an array of 10, say from 0 to 9, how we are going to apply this formula means mid is equal to, what is my low value? Low value is 0, and what is my high value? That is 9. Low and high here indicating the index value of the array, not the element of the array. Okay, whenever we are saying it's a low value or it's a high value, it always gives the index values divided by 2. 0 plus 9 is equal to 9 divided by 2. As we have declared this as a mid variable, as an integer, it always takes the value of integer only. That is, it comes to 4.5 around something. So we cannot take the floating point value. So we have to take the integer value, as array index is of whole integer 1, 2, 3 and 4. Till here array will be divided into one part and remaining array will be divided into second part. Okay, that's what division happens. Okay, divide the array into two parts. One is from low to mid. This is our mid value 4. From low to mid we are dividing into the one part and from mid plus 1 to high. This is my 5th position. So that is a mid plus 1 to high to the 9th position. We have to make it as one more partition. Again repeat the procedure by finding the mid, then partitioning the array into two parts. Again we are using what? Recursion. We are using the recursion, repeating the same step for the first half and for the second half. This by 0 to 4, what I can get, the mid value is equal to 0 plus 4 divided by 2. In that case, that will be 4 by 2. So, you will be getting the value as 2. So, this array is again divided into 0, 1 and 2. Okay, so you have to keep on repeating until unless you should find the atomic value. What is atomic value? Which is not divisible by again. That value is called as atomic value. In this case, what we can say, we can continue this recursion or division using the recursion. How long? How long? Till a single element of the array we reach. Okay, this procedure will be repeated till we get the single values. Then merge all the values to get the final sorted array. Then what we have to do? We have to merge all the single values depending on their values, whether it is greater and whether it is smaller, and then we have to merge accordingly to get the final sorted array. This is how the merge sort will going to work. Let us see the algorithm what we have for the merge sort. In merge sort algorithm, as the first step goes with the start, we no need not to explain much. In the second step, what exactly we are doing, just know what we have discussed, dividing the particular array into two parts. We are using one function called merge sort with the parameters what we have. Array, definitely we are working on the array, means we should pass the parameter as array. One is low value and one is high value. What is low value? The starting index of the array. High value is the last index value of the array, right? So there are three parameters for the function merge sort. We are checking with the condition if high is greater than low. What is the high value? Always the starting index should be lesser than the final index value. This definitely, if you have elements in the array, definitely this condition holds good. That condition will be true. Once this condition is true, what we have to do? We have to find the middle of the element, which is the middle index of the array. We have to find by using this low plus high divided by 2. That's we have discussed in the last slide. Then after finding, what we have to do? We have to call the merge sort. This particular function we have to call again and again for the first half. In the first half, what we have to take? We have to take an array. We have to take the first initial value, first index value and the mid value. Yes, the mid value we have to pass as an argument or the parameter. In the fourth stage, what we are doing? We are calling the merge sort function for the second half of the array. In the second half, how we are passing the parameter? Definitely we should have an array from what is the low element here? Low element is nothing but mid plus one element, because in the first half we have till mid element. So in the second half we should have a mid plus one element till where? Till the last element of the array. So that's after doing this division or the partition of the array, then we have to call one more function called as merge. We are merging the elements of the array once we have divided completely till the atomic value. Hope all of you know what is the atomic value. Till the last element, the element cannot be divided further. The array cannot be divided further. That is called as atomic value. So here how many parameters are we are passing? Array, low, mid and high. We are passing 4 parameters. So merge the two halves sorted in the step 2 and step 3. Whatever the elements sorted in the step 2 and the step 3, we have to merge. Merge the element and find the final solution. We are finding the final solution and we are stopping our execution once the array is sorted. Fine. Let us see this example how the merge sort exactly gonna work. Here we have taken one array. with the index value 0, 1, 2, 3, 4, 5 and 6. Right? How many elements are there in the array? 7 elements are there in the array. First, what we have to do? We have to find the mid value. How we are going to find the mid value? Low plus high divided by 2, right? What is my low value? Low value is 0 plus what is my high value? 6 divided by 2. I am going to get the value as 3. So, we are dividing the array till 3 as a first half and 4, 5, 6 will be at the second half. So, this is what 1, 2 and 3. Now, we have to apply same partition technique or division technique for the second half. What we are doing from 0, 1, 2, 3. Here, what is a low value? 0 is a low value plus 3 is a high value divided by 2. What I am going to get? I am going to get the value as 1, right? That is 0 and 1. And the remaining whatever is there, 2 and 3 will be at the second half of the array. Now, I have to divide this 0 plus 1 divided by 2, that is 1 by 2 cannot be done, that is value 0. 0 will be at the first half of the array and 1 will be at the second half of the array, right? So, now we have reached to the atomic value stage. A single element is there in the array. Now, after this cycle, we go for the merge. We go for what? Merge. This complete cycle, what we are doing? We are dividing. Or we can say we are partitioning. Right? Dividing or we are partitioning. Now, after this phase, we are going to merge the element whatever we have got the atomic value. During the merge process, what I am doing? I am comparing these two elements, right? Whichever the element is lesser, that will be put it in the first index. Whichever the element is greater, that will be put it here in the second index. So, we are swapping the elements depending on the element weight. 38 is greater than 27. So, 27 has to be put it in the first place and 38 has to be put it in the second place. We are swapping the elements here. Then after this half is done. Then compare with this half, 43 and 3. What we have to do? We have to again arrange the element according to their orders, right? According to their orders. 3 is less than 43, so 3 will be at the first place and 43 at the second place. Now, again we have one more partition here for the second half of the array, that is right hand side of the array. So, here what we are having? 4, 5 and 6, right? What is my mid plus 1 value? That is 4 plus 6 divided by 2. What is the value? 10 by 2, that is equals to 5. 4. So, 4 and 5 will be at the left half of the second half and 6 will be at the right half of the second half. Similarly, here low and high value will be 4 plus 5 divided by 2. What is 4 plus 5? That is 9. 9 divided by 2. Right. So, 9 divided by 2 is equal to 4. So, 4 will be first half of the array and 5 will be at the second half of the array. So, now what we have to do? Again, this half has to be merged. This half has to be merged between each other, these two elements. So, 9 is smaller than 82. We keep as it is, 9 in the first value and the 82 as a second value. Then, this has to be compared with this element also. So, 9, 82 and 10, when we are merging these three elements, after 9, 10 is the next largest value and 82 is a one more largest value. So, we will get this. Now, here in this part what we are doing? We are combining these two elements of the array. So, we are rearranging the elements of the array according to their sorted manner. First, lowest value, that is 3, next lowest value is 27, next lowest value is 38, next value is 43. Then again combine these two and merge these two elements of the array. So, we are finding the sorted array. 3, 9, 10, 27, 38, 48 and 53 out of the unsorted array given. This is how the merge sort is going to execute itself. So mainly we have to concentrate on the two parts, that is partitioning, we have to partition or how to divide the array and how to merge the array. Okay, next we'll look into the C code for merge sort. As we know, when we are using the C code, obviously we should include the header file. After including the header file, what we have to do, we are calling two functions. We are declaring two functions which has going to be used in the program. What are the two functions? One is merge sort. As just now I explained you, we have to do the two partitions or two functions called. One is merge sort to merge the element of the array which is divided, and one is partition, means dividing the element of the array. So we are doing the function declaration here. What this part is? Function declaration. Right. This is a function declaration. After that, we are going to do the main program. In the main program, you have to initialize create the array. So A of 50 is array. What we are taking, I and n value. N gives the number of elements in an array. I is used to represent the index value of the array. As so far we have done with many programs in the array, you must know how to give the values to the array, how to read the array from the keyboard. That is what we are doing. We are reading the array. First we have to give the length of the array, how many elements we want within the array. So that is nothing but the n value. Then we have to give the elements of an array, what all the values for each elements in the array. That can be done using the for loop. Within the for loop, we have to give the scanf statement to read the element from the keyboard. That is what we are doing. We are including the scanf statement within the for loop. Then we are calling the function partition. This is what function call. Within the main function, we are calling the sub function called partition, which we have declared it. We are not yet defined the partition function and the merge function. So once we are calling the partition function, control will go to the partition function. This is a partition function where we have defined the partition function. In partition function, what we are doing, just we are dividing the array into two halves recursively, right? So that's what we are doing. We must have an array. We should have a low value and we should have a high value. What we are finding? We are finding the mid value. How we are finding the mid value? First we have to check the index value of the low is less than the index value of the high or not. Definitely if there are elements in the array, index value of the low is definitely less than the index value of the high. Then what we have to do? We have to compute the mid by using the formula low plus high divided by 2. That's what we are doing here. We are calculating the low plus high divided by 2 and dividing the array into two parts, right and the left half of the array. Then we have to call the partition function recursively. Recursive call for first half. Of the array. This particular function is a recursive call function for the first half of the array, where we are using low and mid value. In the second part, this is also recursive call for second half of the array. What is this? Recursive call for the second half of the array, where we are dividing the array right side of the array again with the mid plus 1 value to the high value. So this is a recursive function. After dividing this function will in turn call the merge function, merge sort function. So once we have divided completely till the atomic value, what is the next step we have to do? We have to merge. Let's see what is a merge function does here. In the merge function, how many parameters we are passing? We are passing 4 parameters. Array, low, mid and then the high. Then we are declaring some of the variables with the initializing the value for the variables, where LO stands for low and MI stands for what? Mid of the array. and I stands for also low. Okay, so we are checking one condition where low is less than or equal to mid and mid is less than or equal to high. So when we are checking with the condition for this particular divided array, we have to check what we have to check, whether this low is less than this mid and this mid is less than this high, right? So this what we are checking here. Both the conditions satisfy, condition is true, then it will go enter into the while loop. In the while loop, what we are checking for A of low is less than or equal to A of mid. So index value of the low is definitely is less than or equal to A of mid, right? So A of mid, in that case what we are doing, we are assigning the value of A of low into one temporary variable called temp and incrementing the low value. Next what we are doing, we are incrementing the low value. Else if this condition is not true, the element which is there in the A of low, say consider this is 30 and this is 10, if it is not true, this condition is not true, what we are doing, we are transferring this element, whatever the element is there at the A of mid, that element into the temporary variable called temp. Okay, so 10 is transferred in this case, or in this case here this will be transferred to the temperature. In either the case what we are doing, we are transferring the lowest element into one temporary variable. Next what we are doing, we are incrementing the mid value. Then after the else part, we are incrementing the I value, that is the index value we are incrementing, because we need to compare with the next element of the array. Next what we are checking with if low is greater than mid. If low value is greater than mid, what we have to do, we have to transfer that particular k value. What is k value? K value is nothing but your mid value, that it into the temporary variable. Here in all this procedure what we are doing, we are comparing the single element to the other element. If the element is lower, put it in the first index, put it in the before index, or element is greater, put it in the next index. That's what we are doing. Again, if this condition false, we are going to the else part. Here k is low, so we are assigning the low value to the temporary variable called temp, increment each time for k, right? For k what we are doing, we are assigning the whatever the temporary value is there, we are assigning it into the array. We are merging the temporary variable to form a complete array. That's what we are doing. After this merge sort, we have to go back again to the main function. This is done. Now we have to print the elements after sorting the array. After merged sort, what we have to do, we have to print the elements of the array. That is done by using the printf statement within the for loop, because we have a n number of elements to be printed, so we have to provide the for loop and printf statement within the for loop. Then we are stopping the execution, getting the result back and stopping the execution. That's all for today's session. Thank you.